So what you just saw me do was actually start the recording so that the session that you have, in this session, whatever I'm doing on the screen will get captured into a so-called video recording that you can reflect back when you get back home. So what happens is, when you join this training program, there are some obvious benefits that we extend. One is you'll be a part of a group that you will sign up, and in that group the communication will be sent to your email address. In this email address that you share with us, we will provide you all the updates that are happening in the training program. We will be sending you the links. We will also use this group to share information with the entire group as a community. So any questions that you have, you can post them to the group. Any concerns that you have, you can bring it up to the group, and everyone will be on the same page. Here you will also get the communication from Amol, which is covering the training program. Any training information that you want to get. Any updates that are there for the training curriculum, right? And any changes that are there in the training curriculum. All of them will be provided to you in this group. This group will also provide you the recording information, which will be available for you for review in your own time. So what we cover in the class, you can actually
Hello?
Yes?
Oh, sorry. Ashish got this. I thought I got disconnected again. Sorry.
So what I'm going to start here is give you the brief overview of our coverage, and then we will start what we need to do. So what we do here is the software quality assurance program, in which you will understand what software quality assurance is all about. Why do we need software quality assurance? What are the type of roles and responsibilities as a team member that you have when you join the software quality assurance team in an IT organization? What is your daily activity that you do in the quality assurance team? How do you interact with your team members? What is the team composition? All this will be covered in the training program. Now, to support that, what we have here is a training DVD. So whatever is the notes that we have for you, the coverage that we have during the program will also be provided to you in a training DVD. This training DVD has a lot of information that will help you a lot in your training career here with us in the 8 weeks. What we will do is, what we cover here in the class, you have references of those available in the training DVD. I just have 64 hours with you. I don't have more than 64 hours. So I will cover a lot of concepts, and I would like you to reflect on those concepts using the recording that I share with you, and also the training DVD, which has the more detailed content. And of course, in the following class, after we're done with one session, what we do today, in the following class, you can come back with the questions that you have for the previous class. So first 10-15 minutes are actually used for reflection on the previous class. And then we will start with the program for the day 2, right? And so on and so forth. So this session that we are looking at will be an 8-hour session in which we will have a 15-minute mid-morning and 15-minute mid-afternoon break. There will be a 1-hour lunch. So we have 2 or 6.5 hours of training, hardcore training. This training needs a little homework that you need to get done. So what we cover in the class, there will be some background learning that you need to do for that class. So I would expect about 8 to 10 hours per week that you need to invest, other than your regular job, because everyone has a life to live, right? You have to pay your bills, you have to manage everything. So what you need to do is find some 8 to 10 hours during the week. One, you can reflect on the recording, and this is after you've reviewed the recording. I would be providing you some piecemeal homework that needs to be covered, and then you come back and we'll discuss the homework. Because what happens is, as we have limited time, I cover important concepts, and expansion of those concepts is a part of the homework. And also in the training DVD, the supporting document that you get from me. So this is what is covered here. The DVD contains information about concepts for hardware, concepts for relational databases, concepts for programming languages, concepts for flowcharting, etc., etc. Because these are important disciplines that you need to know when you work as a quality assurance engineer. Let's look at the following details. When you start working here, oh my God, ID is not. Well, everyone is working with this ID, Manju. So what you can do is, if Amol is here, he can help you out. Hey, Amol, are you on call? So while we're working in the class, you can use any of these desktops that are available in the class, and so is the case with the off-site team members. They will get a remote desktop to log in. In that remote desktop, they will be logging.
Has joined the conference.
Hi, who just joined?
Yeah, Ashish, this is Manju here.
Hey, Manju, welcome. So help us fill in this information here for you, and then you can feel free to go back to the system that you're working with. So I will record this name here for you.
I think you already have it.
Yes, I realize that. Okay, thank you. Let's go there and find out more information for you. Okay, so what's your background, Manju?
Yeah, I have the bachelor's degree in computer science from India.
Okay.
And, I used to work as a network administrator with Novel Network. That was, a couple of years back. Right now I'm out of the job market since a while. So just want to get started back on into IT field, starting with QA.
Okay, so you work as a network admin on Novel only. Have you worked on any software and also, or you just worked as a sysadmin on Novel?
I think I'm mostly like an administrator. And I was a certified network instructor as well.
So is that a CCNA, if that's what?
It is CNI.
CNI, okay. Okay, and why QA? Why not go back to your same discipline?
I was actually planning to get it back in, I think, in SAP, but then it didn't work out much.
Okay.
It was very difficult for me, so I thought let me start back with QA.
Okay, so you want to restart IT with QA, right?
Yeah.
Okay, thank you very much.
Sure.
All right, so when we work on these, when we work on the training program, what we do is we will allocate individual units for the team members who are with us. The on-site members will get a desktop in the class, and the off-site members will get a remote desktop. You will log into the remote desktop using Shishya 20 for the remote desktop, and Shishya, the host number which is written on your top left corner here. With that as the user ID, you will log in into the system. When we are working in the class, we obviously need to use a repository where we can store everything, a shared repository. So what we have is a shared network storage, which is also called SAN or network attached storage as NAS, which is located at this location. So what we will do is we will create ourselves a repository here at this location so that we can store everything into this location. So what happens is, if you're sitting on host 1 or host 2 or host 5 and you're remoted into 7001, 7005 or 7003, you still have the same share that you can work with. So whether you log in from host 1 or from host 11, you can still use the same repository and have everything accessible. I would encourage you not to use anything local on your desktop. Because what happens is when you store things locally on your desktop, When you're talking about remote or you're talking about here in class, those units are not available, well, those units are available for other team members as well. So you may have or you may run a risk of losing them. But when we go to the network attached storage, in that case you have the benefit that it is being backed up and it is safe. And you will not lose it. So if you work on desktop 1 and you save it locally and you go to desktop 2 next class, you don't have that data available if you stored it locally. So be aware of that. Next point that I want to highlight is the training related queries that will go to the Yahoo groups which I talked about. So please expect an email coming in from Amol requesting you to sign up and join the group. Next thing that we're going to look at is information about the training DVD. So let's start with that. So what you see here is the content of the training DVD that will be provided to you when you sign up. This has a large amount of data that's available for you to review everything that you want in terms of your software quality engineering career. There are various documents, important documents that are there. In here, some critical documents that I would just share with you. There is a book called CSTE CBOK, which is Certified Software Test Engineer Book of Knowledge. This book of knowledge tells you everything about quality engineering. I would encourage you to find some time to read through this book because this gives you the technical overview of the conversation and also the various steps that you need to execute in quality engineering discipline. And the other thing that I would like to highlight is IEEE Test Plan Outline. Now this document that you have is an industry standard that has been mandated for good planning for software testing. We should look at that as well. And as we go along, I will highlight these documents for importance. But at the outset, I just want you to be aware that there's a lot of information that's available in this training repository that we are sharing with you. All right? You can also look at various sections here. 21 CFR Part 11. This talks about the pharmaceutical industry and the practice that is used in the pharmaceutical industry for validation. So I see a big nod from Nilesh because he has some idea of CFR, right?
Code of Federal Regulation. Code of Federal Regulation.
Absolutely right.
And that 21 probably around Food and Drug Administration CFR.
That is correct.
Yes, I know that. I don't know about the part. There's a chapter about part 1 to 10 up to like 1000, 2000.
Right. So part 11 is basically pharmaceutical industry.
Okay.
Right. So then we have live meetings for one of our previous batches which you can review just in case if you want to find some other areas of technology that you were interested in. Then you have something to do with CMM, Capability Maturity Model. Has everyone or anyone heard about ISO or ANSI? You have heard about ISO, okay. So what do you think ISO stands for?
ISO stands for International Standard Organization.
International Standards Organization. What do they do? 9001 is a certification for manufacturing industry, right? So there is ISO 9000, ISO 9001, 9002, and so on and so forth. So what happens is there are standards that are defined. If you meet those standards, you get the ISO certification, which means that you are a quality organization that has documented processes that are followed for everything that you are doing. Similarly, CMM is Capability Maturity Model. Capability Maturity Model helps you understand about an IT organization. Does this IT organization have a proper procedure and documented steps for everything that they are doing? Are they looking at proper way of managing change? Are they looking at a proper way of implementing the change? Do they have all the necessary checks and balances that are needed at each step? Or it is just a chaos in an IT organization? So that's what defines the standards. And if you meet those standards, the organization gives you a rating. Unlike 9001, 9002, etc., CMM is defined in CMM level 1 to 5. So every organization that wants to get certification is at level 1 to begin with. That's the initial phase or the inception phase. As you mature in the documentation and processing methodology that you have, and you start following rules and guidelines, your assessment is done from CMM level 1, you'll become 2, 3, 4, and 5. And CMM level 5 is the top rank that you can get. All the IT support organizations like HCL of the world, Cognizant, Infosys, Wipro, all these organizations, Tata Consultancy Services, these are all CMM level 5 organizations. Why do you think there is a benefit of accreditation like this? Why do companies get accreditation? Anyone? Online team members, any feedback? Why do you think organizations are interested in getting accreditation?
This is Julie. Companies want to get accreditation because customers want to do business with companies that have proven quality track records.
Absolutely right. Accreditation provides a certification that we mean quality. We give you good business in terms of service, in terms of product that
has left the conference.
Support that we provide. So we have a good documented process in which we can manage what you need. So have you heard about a doctor being certified and that's your preference because you want to go to that doctor who's certified? Have you experienced that? There is a doctor and then there is a board certified doctor, and your preference is always to go to your board certified doctor. Because why? You understand that the board certified doctor has more technical prowess, right? He is technically more sound in terms of his experience and capabilities as compared to the other person. So what happens is these accreditations help you establish your credibility in the market. And as you establish better credibility, you get more business. So that's why CMM came into existence and it gets acknowledged in the industry. The next thing that we're looking at is the documents base. There's a lot of information in terms of this folder, the various type of documents that are included in this. Let's take a quick look here. Some of the documents are homework assignments. Some of the documents are general information that you can use here. So there's a lot of documents that you can see here. And the next thing that we're looking at is a knowledge-based repository. In this repository, we have lots of books. We have a lot of concepts that you can use on. There is concepts for C programming. Linux books are there. TCP/IP is there. Testing folder, separate testing folder is there. Then we have testing tool comparisons. We have e-commerce testing process. So there's a lot of information that exists in this training DVD. Then the next that you're looking at, Load Runner, QTP, Quality Center, Silk, Test Director. Now these are some important folders that we have here in which you have the training manuals and the user guides of all these tools. And these are the so-called repositories of information that are shared by the tool itself to their customers. So these are available here for you to review. Then you have a utilities folder in which you have some information like, it may be old, but then there is Acrobat Reader that everyone needs to open a PDF file. So you have that in there, plus some other utilities. Then you're also looking at something to do with Agile. This is a development methodology that is very prevalent in the marketplace today, where all IT organizations want to start. So overall, there is a lot of content that sits in this repository, and this relevance of these documents will come along as we move in the training program. So with this, let's go back to our training document that we were working on.
Has joined the conference.
Was there a question? Is there a question? Hello? Anyone?
I believe someone just joined the conference.
Okay, all right. So now what we're going to do is, I would encourage you to have this training DVD handy with you during your class, so that you can refer to these documents as needed as we are working on them, correct? Now, what we have here is a training syllabus, which is a guideline that we need to follow for these 8 days. It's broken down into each day, and we've tried to manage it for every 15 minutes, half an hour that we want to cover here. So that gives you a brief outline or a broad outline of what is the course content here. Now, this course content is a guideline. This can be altered based on the need of the class, can also be modified based on your expectations. We can manage that, right? So this is a guideline that we need to follow. So we will try to follow it as much as we can in terms of the coverage. Now, every session that you have is divided into various areas that we need to cover. Similarly, each day is divided into sessions, and you will find concepts of the sessions and concepts of the subjects that we want to cover detailed here for you. So I don't want to spend time to go through all these at this point in time. You will have a copy of this, and you can review it and understand what we're going to do here. Then we're talking about some highlights about our training programs here. What we do, what kind of training we offer, what are the services we offer, which is also a part of this document here for you to review. And as we progress, we will go into an important subject that we want to start with. This is where we actually start reviewing our training program. And we start working with understanding a general application. This is where we will break into the actual technical discipline for our training. So before I go into explaining what I have on this slide here for you, I would like you to have a brief exposure of you getting associated with a software quality engineering program. When you want to work as a quality assurance engineer, your role and responsibility is to test a system. I'm sure everyone is already aware of that. But what are you testing? Any idea? Anyone? What are you testing?
A software which is developed by the programmer, whether the output is coming correctly according to the requirement.
Okay, one small request that when you respond, since people are not familiar with the voice yet with everyone, I would encourage you to say your name first, and then answer the question. My fault, I should have said that as a precondition. So we just heard from Urmi where she's saying that what you test is basically a program that has been written by a developer, and you test the output based on requirements. So that's what a quality engineer does. Do you think it's the same thing, Nilesh, or you have some other thoughts and ideas? Yeah.
And one more thing, in the programming, QA also says the flow of the program is going correctly or not.
So I think what you want to say is the business flow of the transaction needs to be validated.
Yes.
Okay, that is good. Definitely. That also is a part of our testing effort. I agree with you on that. So Nilesh, do you think it's something else that you would like to add to this?
Just saying, might be making the the batch can do the testing, if it is within the requirement, if it is everything fine, even one mistake, then you have to do it again for changing the program?
He stressed and touched on a very important concept here, which is you see, you execute, and you match it to the requirement.
Right.
If the requirement is met, everything is fine. If the requirement is not met, so you start the process again.
Yes,
Right.
yes.
Now, but before you start the process again, you need to understand what can be done to fix that problem.
Right.
You will fix that problem and then start doing it again.
That's it.
So this is what a quality engineer does. A quality engineer, role of a quality engineer is to look at the application. Is the application behaving as it is expected to? Right? So what defines the expectation? My requirements define the expectation. So we will have a set of requirements based on which we will develop an application. When this application is developed, needs to be tested that the application does what is expected to do. And that's where the quality assurance team comes in. The quality assurance team comprising of a QA director, depending on the size of your organization, you have a QA director as the top person in the management team. Then under the QA director, you have QA managers. The managers have the responsibility of managing the team, managing the resources that are needed in the team. What will happen at which stage? Do I need more team members? Do I need lesser team members? Do I need automation? Do I need to buy automation tools? So that's the manager role. Under the manager, you will have the QA lead. Now, lead is the person who is technically sound and understands the application very well, has good understanding of the technology that is being used to build the application, and is also very, very well versed with testing methodology. And he is supervising his testing team, who is actually executing the test. So from the QA director to the QA manager to the QA lead, now we come to the senior QA analyst. The analyst is responsible for analyzing the requirements and making sure those requirements are met by creating test cases. So there is a QA analyst, there is a senior QA analyst. Depending on the hierarchy and experience that you have, you will have the QA analyst role. Then there is a test engineer, which is the first step in QA IT. So test engineer is responsible for executing test cases and reporting on them. So as Urmi and Nilesh mentioned, that you have requirements and you test against those requirements. They are to be tested on basis of some test cases, which are written by the analyst who will analyze and create these test cases. But they will be executed by a tester, right? So a tester is given a set of test scripts, which are created by the analyst, which are done on the basis of the requirements, right? So that's the hierarchy. So a test engineer executes the test cases and confirms that it meets what is expected in the test case. He may not know eventually what the requirement is, but he will know what is the output that is required from this test case. And if the output that is coming out of the test case is fine, then the test case passes. Now, for example, I as a test engineer, when I work on certifying some test script, let's say my test script is I open a web-based application, and that web-based application has a user authentication challenge. So it's like, I am going to log into my Yahoo email account. So what are the steps that I need to follow as a test engineer? I would find a computer that has the expected operating system and the right browser, and I will invoke the website. Once the website is open, then I confirm that the website is
Has left the conference.
what I want to see. And then I log in, and after login, I will have my steps that I need to confirm. So that will be my test engineer role. this is what is a brief background about what a QA resource does in various roles and responsibilities. So from the test engineer to a senior tester to an analyst to a senior analyst to a test lead to a test manager to the test director. That's a complete hierarchy, composition. These can change. You may have senior testers, you have an assistant manager, you have a manager, you have a senior manager, you have a director, you have a senior director. Depending on the size of the organization, these things can be very fluid. Typically, a manager is not a very hands-on person in terms of execution of test cases or reporting on test cases. He's more on managing everything, right? A senior test analyst, a senior senior QA analyst is guiding how the QA analyst and the tester will execute their work, right? So let's understand that team hierarchy, the team composition. Is everyone clear on that? Online team members, are you clear with the team composition that we just talked about?
Yes.
Was that Ben?
Yeah, yes. This is
Okay. So please let's try and make it understandable for everyone that when you respond, make sure that you mention your name first, because I also cannot make out all the sounds yet. So I need to understand who responded. So Ben, thank you very much for your response. So any questions on the team composition or team understanding or team roles and responsibilities? Are you clear with this?
Yes.
Yes.
All right. So now let's understand what happens when we are looking at an application. What does an application look like? So when you access a website, a favorite website that you have, let's say you're trying to run a search on Google, right? Everyone uses Google, right? So what happens when you search on Google? How does it start? You're sitting at your home.
Has joined the conference.
You're sitting at your home on a PC, right? Your personal computer, but you could also be on a laptop. You could also be on a tablet. You could also be on a handheld device like your cell phone. Which means what? There's a diverse platform that can be used to access the internet. Right? Everyone agree?
Yes.
Okay. So the next thing that we want to understand, what we have here as a platform is just a simple base of operating system. It could be Microsoft NT, Network Technology. That's what it used to be at one point in time. Then came Windows 2000. What's the latest Windows operating system that you have now?
2007.
What's the latest operating system that we have from Microsoft?
2007.
It's just Windows 7, not 2007.
7.
Windows 7,
Yes.
right? Windows 7 is a PC-based operating system. But there are some server-based operating systems as well, which we will talk about later. You have Sun, you have HP, you have IBM, and then you have Linux. Hello? Hi. Absolutely.
You remember me?
I do remember you long back, but I'm sorry I forgot your name.
Yeah, my name is Alex.
Alex, yes.
Yeah, just was like in October. I just came here.
You came here for a brief.
For couple hours. Yeah. And now I decided to join the class. Probably, you know.
Oh, please.
I spoke with Jake. He knows. Actually, okay, I'll discuss later.
Okay, all right. So we have a new team member joining us here. His name is Alex. Everyone on call. So we're just starting up. We're just doing a brief introduction of what the program is all about, and we're starting on what is the technology stack that we should look at. So here, I'm just trying to work with what an application is when you're trying to access from your environment. You're looking at a PC, you're looking at a tablet, you're looking at a laptop, you're looking at a handheld device that is based on one of these operating systems, right? Is there any other operating system that I'm missing here? Unix is there. Unix, Linux, Sun, Mac. Of course, Mac is missing. Is there anything else?
Works for you, but
Sorry?
What's your move?
Whoa, you took them back to Adam and Eve. He's talking about mainframes. Mainframes are definitely here to stay. They're not going anywhere. A lot of organizations still are very strong on using on these operating systems. But since these are not very prevalent in the consumer marketplace, that's why you don't hear much about it. All the financial services organizations, health services organizations, and a lot of manufacturing companies are still operating with those systems.
AS400.
AS400 is another operating system that's not here in this. Because majority of the testing effort that we do is for consumer-centric applications. But to understand the technology that's available in the marketplace, those are also important things that we need to be aware of. There's Android as well, which is missing, and it is catching up very fast. So those are the operating systems that exist in the marketplace. Why do we have so much diversity in operating systems? It's like, why do we have so many cars? Why can't just Ford be good enough for everyone to use? Because every car manufacturer has its own special features in terms of safety, speed, luxury, comfort, right? Similarly, these operating systems also provide their own benefits and advantages. Some of them are in the competing area. Like Microsoft and Mac, yes, they are in competing areas. But there are preferences people have for one versus the other. They share the marketplace, right? So we need to understand the platform. So why do we need to understand the platform? How does it help me in testing? Different setup. Not sure if everyone comprehends it, but different setup means when you have an operating system, you have a software based on that operating system. That software has to play along very well with your application. For example, when you're trying to access a website on a Mac, what do? Safari.
Yes,
that's the browser. Versus Internet Explorer. Versus Chrome. Versus Firefox. So there is a whole variety of mediums that you can use to access from the platform. So when you're testing an application, you need to understand what platforms are supported for the application. More is the number of platforms that need to be supported, bigger will be your testing effort. Try and imagine the testing effort for Google. How much testing do they do when they execute a test effort on a build that needs to be rolled out or a change that needs to be made in the application? Right? So this is to give you a brief background about the platform. So now you've decided about the platform. You have a PC which is running on Windows 97 at your home. What is the next thing that comes into picture when you want to access the internet? Before the browser, there is, well, actually, let's go with the browser itself. So the browser that we have here, there are a lot of varieties in the browser as in the marketplace as what we see now, right? We have, this is actually an old slide that we have here, where the marketplace was divided between Internet Explorer and Netscape. But now, there is a huge share for a lot of other people also in the market. So we need to look at the browser also. Why do we need to look at the browser combination as well? Same thing, like platform, they are specific for different features, right? Now, when you talk about a platform and a browser combination, some of these platforms can be common for multiple browsers. For example, on on Windows 7, I can host an Internet Explorer. I can also host a Firefox. I can also host a Chrome. I can also host Opera, which is another browser. So why do we have to test across browsers?
Like each and every browser has a different like lookout. Some like if you may create a browser in the Internet Explorer, so you cannot see on the Mozilla.
And each browser has its own style. I mean, the way of presentation is different in each and every browser?
Very good point. So when you're looking at your operating system, which is your platform, on that operating system there are hooks for this software, which is your browser. And every browser uses different type of hooks to get connected to that operating system. And it interprets the page that is being displayed on that differently. So what I see on Chrome and what I see on Internet Explorer versus what I see on Safari, if my application demands that it should give same look and feel on all of these, I need to test them. Which again boils down to how much is funding so that you can test across multiple platforms and multiple browsers. So when you have this kind of condition where your application is to be supported on multiple platforms and on multiple browsers, something called cross-platform testing becomes very important. So on my Windows 7, I will check Chrome, I will check Internet Explorer version 9, 10, maybe 8 as well, which is supported. And I will go into Safari, I'll go into Opera. Why do we need this diversity supported? Because when I'm looking at a web-based application, I don't know where is my user coming from. My user could be using any of these combinations. I may have some grandmother sitting in Idaho who is still working with Windows 98, and we still want to support her when she wants to access Google, right? But I also want to support the bleeding edge Samsung Galaxy 3, which is about to hit the market or already hit the market. And when a user is on a handheld device on a cell phone and executes a request for search on Google, I should be able to support that. Right? So that's how we build diversity based on the budget that is there. Then the next thing that comes in is now the Internet. So how do we access the Internet? Online team members, any suggestions?
Web hosting.
What is that?
Web hosting.
Web hosting is a different concept. Let's not confuse it here yet. Web hosting is actually having a website installed on a web server. That's a different thing. But to access that web server, or for example, I'm trying to access Google, I'm actually trying to access the Google web server. But how do I reach that web server? I need to understand that.
Right.
So that's what we're trying to understand here. So when we talk about the Internet here, we talk about your Internet service providers like the Verizon, the Comcast, the Optimum Online, the AT&Ts of the world, who will give you Internet access. So now, when we talk about the Internet component in the big picture here, we're talking about a service provider who is going to give me the Internet service. We are also looking at something to do with speed that the service provider has. Anyone, any ideas? What is that?
How fast we can access the Internet.
So, okay. In technical terms, we call it as bandwidth. What is the available bandwidth from my service provider with which I can get connected? Right? So when we talk about Internet, when a user is trying to access a website from home, there are multiple options. They could use the 3G or 4G that you have on your cell phone. They could use the cable network from your home. They can use the DSL. They can also use the Fios. And they may also use higher bandwidth commercial services like T1, T3, and T5. The difference is the Internet highway accessibility. It's like a single lane versus 16 lane versus 32 lanes to get connected onto a state highway. So that's how your bandwidth varies. Right? So when we talk about the Internet as a part of our testing effort or the big picture that we're looking at in the application architecture, we need to understand the different bandwidth with which my consumer is going to get connected to the website. Why do I need to know this?
How to check that how fast your application responds.
Okay.
Because sometimes it happens that if your application responds slowly, then the user gets annoyed or
She's hit a very important point here. When you're talking about the internet, you're talking about a diversity of bandwidth with which the customer is going to get connected. So when I'm looking at a variety of consumers coming from different bandwidths, I need to make sure that I meet the expectation on the customer side for response time. Have you heard about an ad which is still downloading? Which is one of these ads which is for a service provider where the software is trying to download something and it takes forever. So what happens to situations like these when the software takes forever to respond? You potentially lose customer if you do not provide feedback in this similar time. Let me give you one quick example on similar condition. You're trying to execute a trade on the stock market. And this trade carries a large sum of scripts that you want to transact. Let's say you want to buy 100,000 shares of Berkshire Hathaway, which is about $150,000 each. So the cost of transaction that you're looking at is 150,000 with so many zeros. I don't know what that amount is, but it's a big, large sum of money. You try to execute this trade, and let's say it takes 1 minute, which is 60 seconds, which is 60,000 milliseconds to complete this transaction. And in this 1 minute, the price of the share that you tried to buy moved up or down before it actually completed your trade. So what will happen in that case? It could hit you hard, it could benefit you well. So that's where we understand that the importance of response and speed of response becomes very critical. Similarly, if you look at our favorite search engine, Google. You know how many search engines exist in the marketplace? Several. Why is Google the most preferred? Is that speed only which is critical? Isn't the relevance of the result set that is given back to you also important for you? Because when you search for anything on Google, you know that the Google is going to give you relevant search data, right? They have done their research, they have done their optimization in terms of response, in terms of correctness, in terms of relevancy with the term that you are searching for, right? So that is why Google just ate up all the other search engines in the marketplace. Has anyone heard about Alta Vista? It used to be a good search engine at one point in time in the 90s, but it could not match up with the growing speed and relevancy what Google had to offer, so eventually just disappeared. Why can't Bing catch up with Google? Why don't we have Lycos, or why don't we have other search engine organizations that can spring up and start serving a very captive audience globally? Because they cannot match up the standards what Google has set in the industry. So when you're looking at performance, you're looking at relevance, you're looking at accuracy of data, you also want to know what is the connection bandwidth with which my customer is coming. So I will have users who are coming from cell phone. I'll have users who are coming from the cable network, from the DSL, from the FiOS network. I want to know when that customer gets connected or the diversity of connection types that the customer uses, what will be my response time to them, which is very critical for us. That's what you typically do in the load testing discipline. So here we define our operating systems that we need to work with. Then we define what type of browsers we want to use, because we want to understand every browser has its own way of representing the data that is received from the web server. We want each of those browsers giving us exact same information in terms of content, in terms of layout, in terms of look and feel. They should be same across. So when a user is looking at on a handheld iPhone versus the iPad versus the laptop versus the desktop, you should see it same across all these units, right? Then comes the internet. I have people who are accessing the internet by using various service providers with different bandwidths. I need to make sure that I am able to reach them in a expected response time threshold. On an average, if you look at a generic website where you are surfing and executing some business transactions, your average response time, if it meets a 2-second threshold, it is considered to be good. So in 2 seconds, when you write something on your browser URL address bar and you hit enter and you get the response in about 2 seconds, that site is considered good. So if you go 3 seconds, 5 seconds, depending on the size of the content that needs to be delivered, it is acceptable. Maybe acceptable, I should say that. Because the content that is delivered has to be aggregated from a huge variety of data repositories. Then you definitely need to do a lot of data aggregation before you deliver. And that's where it takes some time. And it may be for some businesses, it's a good acceptable practice. So now we've identified from the platform to the browser to the internet access through your service providers. Now you reach the website. Now this is where I am doing my hosting of the website. When I look at the hosting of my website, I have different options. I can host my website on a server. What is a server? I can store application on my desktop, on my handheld, on my laptop.
On a web server, but globally everything can use.
Okay, let's understand first what is a server. What do you think a server is? Anyone from online, please? Let's keep hearing from the online team members as well. Who's this?
This is Julie. A server is a powerful computer.
So server is a powerful computer. So
Well,
did have Red Bull, that's how it became powerful? Julie, you say that the server is a powerful computer. How does it become powerful? Does it go to the gym regularly?
No, it has memory, it has...
In terms of configuration, a server has more beefed up configuration. It has better processing capability. It has better memory storage availability. It can work faster because it's having a different chipset. So the configuration is what makes the difference, right? So I have a laptop and I also have a server. Now my laptop is working on a chipset, which could be Intel's chipset, AMD's chipset, so on and so forth. My server will also have a chipset of a similar organization like Intel or AMD, but it will have much higher capacity to process information. So when you talk about processing capability of a server, you measure the server capability in MIPS, MIPS, million instructions per second. So the MIPS that you have for a server chipset versus a laptop chipset is a big difference. So how does it get to that level of processing capabilities? That's beyond the scope of our training program, right? How do they make chipsets that are able to manage better MIPS? How are the chipsets more with a better bandwidth, or the way they get connected to the motherboard? All these things are basically what are the big differences between a server and a device that we use at home, a personal computer or a laptop, right? So it has better configuration in terms of processing capability, in terms of storage, in terms of memory, in terms of the read-write ability, right? So that's what is a server. So a server will host programs, not necessarily just your web program. It could be anything. So what is a server? A server receives a request and processes the information and gives it back to you, right? So that's a server. In a restaurant, when you walk in, there's a server, right? You place an order, the server goes to the kitchen, gets the food processed, brings it back and serves it to you. So that's the concept of a server. But there are various types of servers that exist in the market or in an IT organization. Some of the servers that you may have heard about is your chat server.
Ashish, is Ben speaking?
Yes, Ben.
Actually, server means we can say it contains all the information, right? We can say it's like that, or?
Server is not only just to contain information. There's a lot of things a server does. A server is a beefed up configuration machine that can do various functions. Among the various functions that we are going to talk about, we will know that it can be, based on the function, become a server of that nature. For example, when you're looking at a web server, you're looking at a server that is able to receive requests, process the data for web pages. That's how it becomes a web server. Similarly, when you're talking about a chat server, so a chat server is receiving a request for chat where there is a sender and there is a receiver. So the sender and receiver are communicating to each other as clients, but they're using a common chat server which knows where the request is starting from and where it is destined to go. Similarly, you have print servers. So what are print servers going to be capable of? They're going to request, they're going to receive requests for printing and dump it onto the printer to process it. So that's your print server. Similarly, there are telephony servers which are specializing in telephone communication. Has anyone used Skype?
Yes.
What does Skype do?
Yeah, we use.
That's also an enhanced form of a chat server, but they have video sharing. So what do they do in sharing? They receive input from one resource and share it on the screen of another resource. So similarly, a concept of a server is basically to receive and provide. That's it. And depending on the function that it is associated with, it becomes that kind of server. There's a print server, there's a fax server, there's a chat server, there's a telephony server, there's a web server, there's an app server, there's a database server. So many of them are there. So when we talk about this green thing which is in the center, it's got nothing to do with environmentally green. It's just green because of someone preferred to use this color here. We talk about a web server. So the web server is responsible for receiving a request for a web page and processing the request and providing the information back. So when we talk about a web server, there are various players in the marketplace. There is Microsoft, which is with Internet Information Server, IIS, that can be used. Then you have Netscape, which is doing NAS. Then there is Apache, and there are some more servers that exist in the marketplace. So can one of you volunteer for some questions for homework? You can just type it down and send it to the group in the end. Is that possible? So Urmi is volunteering. Thank you, Urmi. So my question is, what is a server? You can just type it in a notepad or keep it in a Word document and send it out later. What is a server, right? What are the various types of web servers in the marketplace? So we have some examples here. There's Microsoft IIS, there's Netscape, there's Apache. What is that so for? Various types of web servers. Basically, what are the market players? Right? And of course, when you're talking about multiple market players, you also want the market share for each of them. Then the next thing that you're looking at here in the application architecture that we have on slide here, there is a web server, and then there is another additive to that, which is the accelerator. So what do you think an accelerator would do?
Carry data, and like a normal accelerator, we pass that concept.
We pass what? So you have to complete your sentence. I'm not sure what you want to say.
Data.
Data.
Or the information you can say.
Well, accelerator is basically to boost. Now boost what in this case? We're talking about boosting the performance. How would the performance get boosted by an accelerator? When you make a request to a web server, what happens? Let's say you're making a request to serve Macy's.com. That's the website that you want to render. So what happens when Macy's.com is submitted in your browser URL address bar? You start with the browser, which is the orange unit that you see on the slide deck. It goes through the internet. It reaches a host that has DNS associated with Macy's.com. So you reach the web server. Now, when it reaches the web server, Macy's.com is mapped to a file that exists on the web server. That file has some program associated with that. That program has several steps that it needs to execute to create content for the Macy's.com homepage. It has a left navigation bar. It has a right navigation bar. It has a header. It has a footer. It has a body. So all that is written in a program which is listening for Macy's.com. So that content that you have is now being picked from the underlying layers of the application. So it may have to make a database call to get content about promotions that are going on. It may look at some content which is in terms of some user authentication information that needs to be going on. You may have a user authentication for card members on Macy's. You may have some other content that needs to be displayed dynamically on the website where there would be a revolving image or something. So all that content gets created on the web server and gets served. But at the same time, there are thousands of people who are trying to access this Macy's.com website. So if the server has to do the same thing for every request again and again, it means consumption of time and resources. So what we do in this kind of application architecture, when we know there is repeat requests that need to be processed by the web server, and the content on those can be same, we start to use accelerators. So when a web server receives a request, it also passes that request internally to accelerator where the information gets stored. So when a request for Macy's.com is executed by Alex, he's the first person who makes a request to the website. That request, since it has a lot of activity it needs to process from the rest of the components in the application, it executes that. Let's say it takes 3 seconds for the request to process everything that is required on the Macy's.com website. And it gets delivered to Alex. Now comes Urmi, who's trying to access the same website. But my web server is intelligent, and I have built the application architecture in such a way that when I know the part of the page that I serve to Alex will be common for Urmi as well, what I do is I push it to my accelerators in which I store the information. So what happens is, instead of the 3 seconds that I used to build that web page which I serve to Alex, I will go and check up my accelerator and pick up the information from there in probably half a second. So what will happen now? I took 3 seconds to build the page for Alex, but for you, I just spent half a second to capture that information and be prepared to serve it back. So that's what the accelerators do.
So does it mean the web server keeps all this information in memory, physical memory?
Broad concept is oriented towards storing this information in memory, but not necessarily on the web tier itself. It could be outside the web tier. It could be on a separate host, which is an accelerator.
So basically it keeps in memory.
It keeps in memory, but your concept is correct. It stores in memory, but not on the web server itself. Right? It stores in memory. Let's understand that. Yes, that's absolutely correct. But physically, it may not be on the web server because there are capacity constraints, right? You will run out of memory if you start keeping all this information here. Now, there are organizations, I'm not sure if you may have, you may not have heard about an organization called Akamai. Akamai is an enterprise which thrives on caching the content that you want. AKAMAI. A-M-A-I. Akamai. So what Akamai does is it provides you the accelerator feature by its distributed global network of web servers. So when I make a request, let's say I'm sitting in Argentina and I make a request for Macy's.com. If I have Akamai, it's called Akamization of my website. If I have Akamized my website, the request that originates from Argentina will go to a local Akamai server dedicated for Argentina. And we'll find out if Macy's.com exists in my memory. If it exists in my memory, then it will serve it from there itself. If it is not there in my memory, I will go to the Macy's.com origin server if it is hosted in US. I will make a call to that. It will bring it back to Akamai server, and from Akamai it will go back. Now, next time anyone from Argentina makes a call, I don't have to do the round robin and I have to travel, 5,000 miles and then come back. I can just come back from Akamai itself.
For how long does it keep it?
You have to program it the way you want it. If your content is static, like SSA.gov, right, that content never changes. Versus CNN, content is changing every 5 minutes. So you have to define something called TTL, time to live, for that content. So your TTL could be a few seconds, your TTL could be never expiring, right? So that's what the accelerators do for us.
Okay. So in short, accelerator is one kind of a physical part which is attached to the web server.
To the application architecture, not just to web server.
Okay.
Because accelerators can be used at various layers.
Okay. So it is one kind of a physical part which is related to the server.
Yes, it is related to boost of performance. It's a steroid. It's a shot in the arm which will boost my performance. Great, that's it. It's the Red Bull for energy. Because it will increase the speed of response.
But it's a chunk of memory allocated for all this.
It may be for these components as well. But accelerators are normally preferred on the web tier itself. But also remember, these web tiers that we have and the other components which we are starting from, the browser, the internet, the web, etc., they also have their internal mechanism which is also called caching. Your browser caches a lot of content, right? The temporary internet files that you see on your browser, those are caching, right? So sometimes what happens is when you have a Macy's.com website delivered to you and you navigate to the next page, that next page may have some content that is on your previous home page. So instead of making a call to the web server, it may just pick up from your local cache itself. So that's another form of acceleration that exists on your browser itself. Make sense? So the web server has specialization to serve web pages which are built by support of all this that you have here. Right? Then the next tier, which is in the application side now, this is my customer, which is the browser, the platform, beyond the internet on your left hand side. What you see here is the customer. What is towards the right hand side of the internet is my application architecture. This application architecture has various components. We have the web component, then we have the application server. So application server is basically built to handle the business logic condition. The web server, let's say you're making a reservation for travel, orbitz.com. You want to buy a ticket for travel from New York to LA. So that request comes in to the web application. Now the business logic is identifying all the airlines that cater to this sector on the date the customer has preferred. So what do? You come back to the application server, give the request, I need flights from LA to New York and New York to LA for this date. So this application server has the logic to find out what airlines are operating in this time, what are the prices, what are the available number of tickets, and provide that information back to the web server so that the web server can construct the page and give it back to the customer. The business logic about availability, airlines, etc., is being done here in the application server. This tier also has some specific business processes that will be executed. For example, shopping cart, right? Handling of the shopping cart, handling of similar business operations where you have credit card processing. Pretty common for a lot of e-commerce websites. So all this is done here in this, and there are specific software that has been created to manage all this. This is your application tier. Now, after the application tier, we also need to understand that the data that is provided to the application has to come from some repository. That comes from the database. So what is a database? It's a storage repository to store and serve information. Right? There are various types of databases that exist in the marketplace. There's Oracle, Microsoft SQL Server, Sybase, Informix, DB2. Any other database that you are aware of? Alex is going to come out with something. I knew it. So Alex is from the world where things were big, but they were fast. They were very, very fast. Even today, we cannot match up the processing speed of the mainframe. The reason why mainframes are not as popular, because the instant gratification of business is not met by them. Because they are able to, business wants a change and they want them now. Whereas in the mainframe world, you cannot make instant changes. It takes a lot of effort for the good old structured system analysis and design to be executed and implemented for making a change. It's not a drag and drop technology that we guys are growing up with and working on. So this is my database. Now, how does the database come into picture with the application? Any thoughts?
Request from application server.
Request originates from the client browser. Let me give you an example. You're trying to log in into your bank account. So let's say Bank of America is the service provider that you have as a preferred vendor. So I go to the Bank of America website and up comes my Bank of America homepage where I can log in. Post login, what happens? It gives me the account overview. How does the account overview come back? From the web server, it makes a request, give me the overview details of this customer. It makes a call to the application server. This customer, what all accounts does it have? Request goes to the database, and database tells that this customer has a checking account, they have a mortgage account, they have a credit card account. And these are the current balances of each of these accounts. So now, the web server, the application server, and the database server all put together work to get the content of your overview page and send it back to your browser via the internet. Yes, go ahead.
Does it mean when we make call from browser, website, yeah, and you bring us to the page, does it mean that web browser or web server already created connection to application?
To the database?
Yes.
Absolutely.
So just you have like front end ready.
You're just looking at your presentation tier, which has data that has been shared from the database, because database may have some promotion details.
Yeah, I understand. But as soon as we see this page, front page, yeah, does it mean that you already have connection to application? So you know.
Okay, I think what you're going with is, if I have a Macy's.com web page served here, does that mean I'm connected to the database? Is that what you have in mind?
You got from page already, Macy's.
Right.
ready to input data.
Correct.
Does it mean that you have already connection to application server or web server?
Okay, there are two things that you have here that I can break down and help you understand that. First thing is, what you are seeing on your screen is not directly connected through and through.
It's just presentation of...
Even the presentation is not connected to the web server. Because what happens is the technology on which we build applications, it is stateless. So I make a request to the web server processes that request, sends that information back, and after that, it does not know what I want. There is no connection between the presentation and the web server at this point in time. But in conditions, there may be a memory of the request that you've made. So those are session variables that are stored.
It means as soon as you input data to fields on web page,
okay,
and hit enter,
right,
then only create connection to
okay,
or put on queue or somewhere else. Yeah,
so you submit, let's say you're submitting your user credentials on the Macy's.com website. It comes to the web server. Now, the web server has a pre-existing connection to the application server and to the database connection. So it utilizes that existing open connection to process the information. If it does not have a connection, it will establish a connection and process the request. So when you put in your request and when I put in the request, it utilizes that connection, processes the information and sends it back. Now, before that connection that I have expires, there's a time to live for everything here, right? Human life also has a time to live. Similarly, the connection has a time to live. So if that threshold has not expired, the web server will automatically use the available open connection to process the request.
Always some open connection.
By default, when your application boots up, right, it establishes X number of connections with everything inside. So, and it is constantly pinging those connections. It's called the heartbeat. Is the database available? Is the database available? Is the database available? There is a constant loop that's going on in the background, which is done by the web server system. Right? So the web server is constantly pinging the database. Are you up and running? Are you up and running? If you're not, I cannot serve. But in conditions when you're looking at making a transaction on your banking website, let's say you're transferring money from one account to the other, all the systems on the web have stateless connection. So they request, it gets processed, it serves content, and after that, done. Next time when you make the request again, it carries some session data based on which the web server recognizes you as a previous requester. Because when I log in into my bank account, I'm not writing my authentication information every request. So what happens in that case? It knows you already how. Because with my user authentication request that I made, it assigned something called a session variable or a cookie. Right? So that cookie travels between the web server and the client. That confirms that this request is coming from the same source. So millions of people are looking at their bank account at one instance of time. But each one of them will always get the information specific to their account only. How does that happen? This happens because of the session variables that are set. Right? Good question. So the database has now provided the information to the app tier. The app tier goes back to the web server and serves it back. This is a part of the enterprise which is customer focused. But in an enterprise, we also have various employees working in different departments. Right? We have a HR system. We have a financial reporting obligation to the IRS. There are other obligations that we need to meet in terms of federal regulation. So we will have some internal systems as well, which will be maintained in the back office. I will have my manufacturing systems. I will have my marketing systems. I will also have my financial payroll, my business accounting information. All that is done in the back office system. So let's take an example of Macy's.com. Macy's.com is being served from the web server, but Macy's has employees also. Macy's has stores as well. Macy's has requests for replenishing merchandise. They have vendors all over the world. How do they manage all that? They are managing this in the back office here. And this back office is supported by systems like ERP solutions or implemented custom solutions that you will build in-house. So some of the ERP solutions that we have are Oracle Apps, SAP, Siebel, PeopleSoft, Clarify, Bond, and I2.
This database in all the systems is different of the databases which are behind
the back office?
Yes.
It can be same, it can be different. It could be both. Because you could have this data repository that you have, which is common, but it is divided to serve my web application and my back office.
The same server, with different table spaces, for example.
Absolutely. So what happens in Oracle is you buy a database server, and then in that you call a logical partition. And that logical partition is called a schema. Right? So your schema could be dedicated to your web application, or schema could be dedicated to your ERP solution. Whereas concept on SQL Server says that our database itself is different. The host could be the same, but you could have multiple instances of the server running on that host. So that's the big picture of what we understand as technology for us. So based on this, it's good to understand this application architecture in general, because this is what we need to test. When we are testing something on a web-based application, all this becomes important for us. Why does database become important for us? Any reason? Or for that matter, why does ERP become important for us? Or application server become important for us? You have operations that you execute.
It should be being served to
Exactly. So you're looking at when you're looking at sorry? And that is correct. Because when we understand this application architecture in a big way, the big picture, then we understand the components. And when we understand the components, we can certify that the individual components work fine individually, and the sum total also works good. That's what we want. So when I'm looking at the database, I'm looking at when I create a request, which means I am placing, let's take an example of an e-commerce website. An e-commerce website that you can think of? Any website that you buy, sir, that's an e-commerce website. Let's take example of eBay. What happens on eBay? What type of website is eBay?
Internet market.
It's an internet market where you have B2B, which is business to business. There is business to customer. There is customer to customer and customer to business. So all transactions of the e-commerce paradigm are met by eBay, Amazon, Best Buy. All these organizations are e-commerce organizations, right? So what happens on eBay? You are registered as a buyer. You can also be registered as a seller. So when you are trying to register yourself, what are you trying to do? You are trying to create data for a user who will be a registered seller or a buyer. So when you're creating that data, what is happening? You're starting from your browser, over the internet, going to your web server, and storing data in the database. So I, as a new user who is going to be a registered seller, will create a record in the database. That same record will be read from the database when I log in. When I modify my information about the product that I want to sell, What am I doing? I'm either creating or updating. When I want to withdraw products that I am showing on my e-commerce website, what am I doing? I'm deleting. So the database will confirm my CRUD. C-R-U-D. Alex nods, he knows what CRUD is. You know what CRUD is? Create, read, update, and delete. So that's where your database comes into picture, right? Because database is creating data, database is receiving requests to create data, update data, read data, and delete data. Right? So that's how database becomes important for us. Now, when you're doing an exercise of create, read, update, and delete, there is code that is executing that for you. So you want to find that the code base that is used to help you do your CRUD is optimized to deliver the best performance. Because if your individual components that you have here do not have highest level of optimization, you will never be able to deliver a page to the customer in the right time. So when you try to execute a search on Google, Google has this number that you're looking at, one green server here, divided over thousands of web servers. Each of these components that you have, there are thousands of each. That's how the performance that you get from Google is what you want. And that is why the Google stock keeps going up and up and up, because they meet market expectations. And that's the whole line of business. You meet the market expectation, you grow, and you grow, you make money, and everyone's happy. Right? So that's the big picture that we want to set in mind before we get started with anything that you want to do on QA. Any questions on this that you have, I'll be more than happy to answer. Online team members, any questions on this before we step into the next what we want to do?
This is Julie, no question. Yep.
No.
That's making sure that she put her answer right. 3 times she said the answer. Anyone else? Ben, Julie, Manju, Nupur, or Sarita? Anything else?
No, I already responded that I didn't have any other questions.
Okay, all right. So with that being said, we understood the big picture of technology. What we're going to do now is understand the software development life cycle. Now, software development life cycle, also acronymed as SDLC, is the life of the software development process. Software development life cycle. So what happens in the software development life cycle, we'll have a quick overview of that. But before we go into this, let's take a short break and come back. Let's take a 5-minute mind break so that we can refresh, recharge, and get started again. All right? So what we're going to look at is how do we work on a software development product. So let's say we need to build a website, and that website has features for e-commerce. So I can have a user, a customer-to-customer interaction on the website where I will be able to buy and sell products. So that's the broad framework of an application that we want to work on. So when we start working on that, we need to define something called the project plan, the master project plan. The master project plan contains information about how we will process the entire product, right from concept to delivery. Everything will be a part of that project plan. In the project plan, we will also define stages for each of these software development lifecycle stages. So in the software development lifecycle, the first thing that we want to know is my requirement. Who writes and defines the requirements? The business team, the product team, the business analyst who is translating the non-IT business expectation into IT relevant jargon. Non-IT expectation may be my website should be able to accept 100 active users at any given point in time. So how does the IT interpret that? The business analyst or my requirements manager is responsible for translating this into something
Has joined the conference.
I understand. So that's what happens in the requirements. Now, after the requirements are done, they define the product from business standpoint. This is how the application will be. This is the feature that we want in the application. This is how the user password management will happen. This is how much time we expect a user to wait for a response, and so on and so forth. That's defined at the high level in the requirements. Then comes the feasibility. What do we do in feasibility? What business expects? Is that feasible? If it is feasible, what's the cost that we need to pay for that? You may have an absurd request which says that I should be able to deliver every page of my website in less than a second. Can you meet that? Hell yeah, you can do that. But you need $500 million in software and $100,000 million in hardware to be invested. Is the business willing to do that? Then comes the red flags. Sorry, we cannot meet that. If you cannot meet that, then we cannot meet your requirements, right? So that's where we define the feasibility. Now, feasibility will not only look at just the hardware and software cost, it will also look at the technology that best suits you for your product. If you're looking at a web application, is Java the right platform for me? Is Oracle database the right platform for me? Should I go for Microsoft SQL Server? Should I go for one of those open resource databases like Redis, Mongo? So there are various options that you want to do and find out which is the best feasible option for you so that it meets the business needs and also meets the financial cost implications. After the feasibility analysis is over, then you go into the design of the application. What will be done in the design stage? How the business use cases will be executed? How the screens will look like? What will be the error messages? How will my form where I receive an input will be defined? So there are specialized people who are working in the design section here in the software development lifecycle. Those are called the UX team members, usability experience team members. So these UX team members have special skill set. They have done fine arts. They have done user behavior analysis. They have done market research to understand what is acceptable on user interface. What will attract the user if the layout is like this? How will I focus the user attention if I want to have a promotion? What kind of look and feel I need to present to my users so that the application is more pleasing for the user to use? Where do I need to display bursts? Where do I need to display index numbers, etc., etc.? So all that is done as a part of usability analysis, which will become part of the development, the design. Once the design is ready, I start developing my application. That's where my developers have what is needed from my business requirements, which is the BRD, Business Requirements Document. We will also generate another document called FRS, which is Functional Requirement Specification. Then I have the design document. The design document is not only just the presentation look and feel. The design document is also the high-level design and the low-level design of my application as well. When I talk about high-level design, I talk about how the screen will flow. When I talk about low-level design, how my application screen components will talk to each other and with my database. When I talk about high-level design of the database, I talk about what is my table structure. When I talk about low-level design of my database, I talk about how my code will process the information that is stored in my tables and what additional components and objects I need at the database that will serve what I want. So that design is also a part of the design stage itself. Then you go into the development. Once you start developing the application, it will reach a logical state where it can be now tested. So what do you do in testing? You will
has joined the conference.
What is expected as per requirement is being met. So your testing stage complete. Now your application is ready to go live. You deploy the application and it becomes live for the customer to use. When it becomes live, there's a possibility that the customer likes the application but has some issues with the application, makes recommendations, makes suggestions to update the application. So that's where you have post-production support and maintenance. When that is done, you will collect all the information about the changes that you want to make and you will put in an enhancement in the application. Now, since everything has a time to live, so will be life of the application, and at some point in time, you will have a challenge to continue with technology. Technology may become obsolete. The servers that you have on which the application is hosted, they need to change. So you may have conditions where you will actually sunset the hardware or the software and start with the cycle again. So this is what happens in your software development lifecycle. The resource that you use to track each of these stages, what are my various dates that I need to meet? What are my dependencies? How are my resources distributed to each stage in the software development lifecycle? You have a tool called Project Manager from Microsoft, which is a very popular tool that is used for this process. And who's the person responsible for this? As a team member, the project manager himself is responsible for coordinating all this. So a project manager role or responsibility is to see the application is broken down, the entire software is broken down to stages. Each of the stages that have dependency on each other are met at the right time, and if they are not being met, they need to raise awareness of the impact if it does not meet the expectation. Make sense? Now, what we're going to do is we're going to look at the testing component of the software development lifecycle and blow it up for our needs. Because that's what is life, bread and butter for us. So the testing part of the software development lifecycle is now being blown up for you, which is the software testing lifecycle. So what happens in software testing lifecycle? Let's look at that. First thing that we do is we identify our own test plan. And what do we do in that test plan? We define what is the scope of my testing. There are various types of testing that you can execute on an application. Regression. Regression is basically to look at testing what was working earlier, and after the build, there's a possibility it may not work. So we need to test that, right? Functional testing. What is functional testing? When you log into the application with the right user credentials, it allows you to log in. So when you're looking at a function of the application, you're doing functional testing. Similarly, there is GUI testing, graphic user interface testing. Where you're looking at all the objects on the screen are delivered as expected. The state of the object changes when I work with the application, things like that. Then stress, load, and performance. These are other type of testing that are done which are non-functional. So when you talk about stress, how do you define stress?
Really critical. When the system is most busy, to reach the point where not going to take care of
the expected performance?
Yes.
So when we define stress, what we are looking at, let's say my normal business expects 1,000 users active on the system for 1 hour in a day, right? When I'm looking at stress test, I will keep these 1,000 users active on my application, not just for 1 hour. I'll keep it for 4 hours, 6 hours, 8 hours, so that I stress the application beyond the normal level to see what is the system response. What happens to my application if that stress continues over 5 hours or 10 hours. My application melt in the sense
Has left the conference.
do my web servers lose memory? Does my database still perform the way it is expected to do? So that's what is stress. But then what is performance? When I'm looking at user response on a web page, that's what is performance. So stress is extended period of volume of activity. Performance is user response time. My login page should be delivered in less than 2 seconds. Does it meet that standard or not? That's what is performance. And then we have load. As I told you, 1,000 users active per hour on my website. So that's my load test. And I can test my website under increasing load. What happens when there are 1,000 users? If I have 2,000 users, then the application behavior has to be checked. If I have 3,000, 5,000, 10,000, that's what is load test.
What about performance? Does it mean that you're testing scenario when you only one instance, or is just and you get this response time, or do you have like full bunch of people?
Has joined the conference.
It's a little bit more about performance. Talking about execution performance. Someone needs to go on mute. Hello? Someone needs to go on mute. Hello? If your laptop or PC is not on mute, you will hear the echo. And you'll make me feel like God speak when I talk on the phone. Thank you, someone took care of that already. So when we talk about performance, no, I'm not done yet. I am sorry. Hello? I think now it's done. So when we talk about performance, we identify something called a baseline. Now baseline defines what's the volume of activity that goes on an average day in the life of a system. So when you talk about performance tests being done, you are expecting a volume of transactions being processed by different users. So when you're looking at eBay to be performance tested, you have a bunch of users who are signed up as customers, bunch of users who are signed up as vendors who are updating product information. But there are other users also who have already placed order and they want to check the status of their order. Someone is not happy about the product that was delivered to them and they're writing grievances. Someone was very happy about the delivery, so he's writing a blog post on eBay stating that I'm very happy with this vendor, I give him 5 marks, etc., etc. So there are different type of users who are doing different type of things on a website. So when you run a performance test, you look at an aggregate of all these users and you execute those transactions that you would do in life of a system for one day. That's what happens in performance testing. Does that answer what you were looking for? Good. So we define the scope of testing and then we define the coverage. What we want to test, how much we want to test, how many cycles we will run. Because when you are testing, it so happens that when you get the software delivered to you, you start your testing process. When it does not meet your requirement, that means there's a problem and needs to be fixed. So if it has to be fixed, that means development has to take that code, update the code and deliver to you again. And then you have to retest that. Right? So you have to go for cycles of testing before you have full confidence that the application behaves the way it should be. That's what happens here in coverage. Also, in some of the applications, for example, eBay, e-commerce application, when you have a credit card payment that needs to be processed. Now, credit card payment service is provided by a third-party vendor. MasterCard gives you a web-based application against which you can make a request and get a confirmation or authorization that can be processed. So you're not testing MasterCard website at that time. You're just testing your own solution. So the third-party components that get added, you don't test those. Because testing of that is to be done by the MasterCard website. They should be able to confirm functionality of their website. You don't have to test their functionality, right? Then comes what type of method you want to do for testing. Do you want to go for manual testing or automated testing? Why would you have automated testing or manual testing? Why can't you just do simple testing? Is there anything different? Automated testing will help you improve time to test. Because it will do what your manual testing does, but it will be on steroids. You take 10 hours to do, let's say, 100 test cases. But if you automate that, you'll probably be done in half an hour. So there is benefit of an automation tool exactly doing what you want to do in your manual testing and will have this speed to process. So we will, when we go into the automation, we'll see the benefit of that. Then how many iterations of testing do we want to do? Of course, unit testing, which is done by the developer themselves, is an important part. So developer is developing a module. In that code module, they will do unit tests to see that the input and output is as per what they need from the application. Then you go into string testing, where multiple units will function as a string for a use case. Then this string testing will become integration testing, or it will also become system testing when you are looking at end-to-end. So these are the type of iterations that you will do. What kind of tools you want to use? Do I use a project management tool, a project manager? Do I use a test repository maintenance tool like Quality Center or Test Director? Do I use load runner? Do I use QTP? All that needs to be done here. What type of tools you want to? Because when you try to define tools, you need to be aware everything comes with a cost. We have costs that you can put at this point in time now. Then the exit criteria. Why do we need to define an exit criteria? And what is an exit criteria? Anyone? Hello? Anyone?
Yeah, this is Nupur. Ashish, you asked about the exit criteria?
That is correct. What is exit criteria? Why do we need it?
When you're sufficiently satisfied that the application functionality is correct as required, then you will then you'll exit the testing phase, saying that you are satisfied with the testing.
That is correct. So exit criteria is the definition that you need to set as to till what time will you keep testing. We will keep testing till the time we have no bugs in the application. If that's your mandate, application will never go live. Because any application can never ever be bug free. So if there are bugs in the application that we roll out to production, what is quality assurance team doing? Are they getting paid for doing nothing? Quality assurance team will find the defects and let the business know these are the problems, right? The business can take a decision and say that this bug that we have, this defect that we have, this problem that you think exists in the software is not a very critical problem. But business steps that every user will never do to reach that stage of execution. For example, in some cases, it is, I think it was Windows 98 if I'm not wrong, was released on a number of defects. But at the same time, they didn't want to hold back the application to be resolved, the operating system to be resolved of all these bugs, because those bugs The occurrence of those bugs was 1 in a million. Why would you want to hold back for something that will not happen to a consumer when the consumer is using the application or the software? So you would let it go and process it in a subsequent batch if needed. That's what happens here. So exit criteria, when we define our timelines, we also declare our assumptions that this is what we assume will remain fine. Every team member will remain alive for the duration of the project. Nobody is going to just disappear on the project life cycle. They may not change their project work. They may not leave the contract and go away. The application will always be available for service. So these are some assumptions that you will write here. Who's responsible for the state of the application? Your QA manager using the project manager software is responsible for all this here. Then the next stage that we want to look at in the software testing lifecycle is you want to define your project team. This is where we have the hierarchy that we talked about in the morning. You have your QA director, you have your QA manager, you have your QA lead, you have your senior QA analyst, senior tester as the hierarchy. Now, when we talk about a tester, we need to understand that the tester should have some specific skill set. If I'm looking at a web-based application to be tested, I want a test engineer who has experience in testing web-based applications. I'm not looking at an automobile engineer to come and run a QC verification on software when I'm trying to get my web application certified. So I need a person who has relevant skill set. Also, my application has some specific business use cases. Not every application is the same. Banking application of Bank of America versus Macy's.com versus Google versus BestBuy.com. Each application is different. So what I do is I first identify what do I need and who drives this. What do I need? The technology that I'm using. Am I using Java to build my application? Am I using WebSphere as a web server? Do I use Oracle as a database? So based on your technology stack, you define my resources. After I've identified my resources, I go to my HR and tell them, my HR Human Resources Division, and ask them that I need these resources 4 months down the lane for my project. Please request your vendors. Or hire a full-time engineer, full-time employee, and provide me with a resource. So that's the hiring process. So what happens in the hiring process? The manager puts in the request to the HR. The HR will then broadcast the request to the vendors. The vendors will go into their network and pick up a resource relevant to the request. Bring the resume back, give it to the manager. The manager goes through the interview process. Right? In the interview process, they will ask you questions. They may have technical round of interview, a HR round of interview. They may also have a hands-on that you need to execute as a proof concept about your skill set. So that goes on. The hiring gets finalized. You could be hired as a consultant. You may be hired as a full-time employee. Then you're part of the team. Now your team is ready. That team needs to be trained on the business processes of the application. So if you're working in eBay and you're working for user registration process, you need to understand the business process. You need to understand what are the steps that the user has to take. What are the confirmation that I expect that these have to be completed before I am actually a registered user. So all that is a part of the training. All this is again managed by the QA manager, who is going to take care of the team management workflow. After this is done, now we are ready to build our test plan. So what do we need a plan for? A plan is needed to break down our work, to say who's doing what, when, how, where, and how we will complete that step. So that's your plan, right? Any plan has to have these things. So now I start working on my test plan. So what do I do in my test plan? In my test plan, I will define what will I test, who will be responsible for testing, how much time will be required for testing. And for this, we use Quality Center. Quality Center is a tool by HP Woodpecker, which bought over a company called Mercury Interactive, which originally owned the Quality Center software. It was previously called as Test Director because it was a test management application. It was called Test Director. But over the years, as the scope of the testing expanded, the importance of testing was realized, the application also oriented itself to a different name. Right? Instead of directing your testing efforts, it has become a quality center for you, and that's what is the name of the product now. In this, you will be able to do a lot of activities in your testing cycle. As we go into the usage of the application, I will just walk you through. It is not only just for testing, it is also for requirements management, it's also for release management, it's also for defect management, it is also for reporting. All this can be done here in Quality Center. Right? The first few hours of the class are more theory, no hands-on. So if you feel that you're missing out on a lot of stuff, don't feel that. It's just for another up to the lunch session that we have this, and after that we have pure hands-on. Okay? So now, let's assume that our planning that we have to do is done. My test plan is ready, in which I have defined, based on my requirements, I've created my test cases. My test cases, my requirement says, valid users should be able to access the application. Right? How will you test it? Match to what? If my user credentials with which I log in exist in the database, then the user is authenticated and should have access to the system. Right? Okay. I am Bank of America and I am with 10 million users. So will I test all the 10 million users?
No, probably only one versions.
So what your question was segues into the next topic that we have, which is something to do with data here. We'll go into that in a second. Because it's not humanly possible to test all the users. But in some cases, I actually do this. Example, when your banking application is being upgraded, or your bank has been merged into another bank. Right? Fleet was overtaken by JP Morgan. JP Morgan now becomes JP Morgan Chase. So the users who are in Fleet, you put users who are in JP Morgan, and now they are existing in JP Morgan, all these users are with their same user credentials that they've been using for so many years. What do I do in this case? I validate all users can still access. So that's where we go with the full user-based testing. But when you're doing your functional testing, you will look at a combination or sample set of data that will give you reasonable confidence that they will work. So let's say there are 10 million valid users that exist in the database. I'm not saying that you will use 1 million because it's 110. I can say that you will look at data conditions that you think you need to test. And your data condition is you have a valid user ID, you have a valid password, and it meets the business rules. What is a valid ID? A valid ID is, let's say, it must be minimum 8 characters long. Right? it must have an uppercase character. It may have a lowercase character. It has to have a numeric value. So all these conditions, if they are met, we're good. Right? So after we have defined our test plan, the next stage that we need to go into is set up my test environment. Right? I will not be testing in production, that's for sure. And be assured, what I'm saying is truly honest. You don't test in production. Some cases you may be doing testing in production for free cases, but you will always test in a different environment. You will not test in production. So what happens is, depending on the investment the organization has done, you will have a development environment in which our developers will keep updating code base. Once they have confidence that the code base is stable enough for us to work on, they will put it into a QA environment. And there we will beat the hell out of the code, identify what requirements are met, what are not met, fix the defect, and then finally the code will move to production. So now we have three different silos. One is development, the other is quality assurance, and the third is your production. In some cases, your quality assurance silo that you have may be distributed into multiple silos, where you can do functional testing, you can do performance testing, you can do capacity testing, etc., etc. So we define our environment. In this environment, we need some automation tools. We also need the AUT, application under test. Not user acceptance testing, if that's where you're going. Then, along with this application, we also need data. Why do we need data? How can you test an application without data? Absolutely right. If I were to test the Social Security Administration website, what do I need? All the users who have Social Security in the US, I need them to be available. That's the only way I can check that various data conditions are being met. I'm trying to test for a search engine. What kind of data do I need? What he's just referring to is whatever searches the users are doing in active production environment, you want those search terms to be available for you in your test environment, so that you can see what the user does. Right? Is that what you have in mind? So what you do is you have your data in production environment, you pull that data into your test environment, and then use that data. Now, when you look at that data set, the test data that you have here, you have two types of data that exist in a system. One is the transactional data and the other is master data. Now, master data that you have is long-lived. It does not change that often. For example, on an e-commerce website, you are a registered user. And this registered user buys a product on a website. So these two data sets that I've told you, one is a registered user, the other is user buying something. What type of data these are? Are both master data? Well, so registered user is the master.
And type of product also.
So type of product that I bought, yes, that's also master data. But when I bought a product, that is transaction. So anything that's long-lived, which does not change for a long period of time, is always master data. Whereas which keeps changing frequently is transactional data. I bought one product at this price and I want it delivered at such address. That's a transaction. So how do you analyze the data on a banking website? When you are a registered user of a website on Bank of America, what type of data is that? Master or transaction? Master. When I want to make my mortgage payment, is that master or transaction? I want to transfer money from my credit card account to a vendor. Transactional. I want to transfer money from checking account to saving account. Transactional. The balance that I have is master or transaction. Balance will not be master. How will balance be master?
Oh, every day changing the balance.
Balance will change.
Yeah.
Well, I have 5 types of account on Bank of America. That's master. The balance in that account will be changing. That will be transactional, right? Certificate of deposit is master because it's going to live for 1 year, for 6 months, for a quarter, right? That's long-lived data. So that's master data. Transactional is it's going to change on a regular basis, right? So we get the data for testing, and then we get started with testing. Now there's another term that you're looking at here, which is control test data. Why do you need that? These are some of the use cases that you want to use with this data for smoke testing the application. Now, smoke test is not smoking like a smoke of a cigarette or a cigar, but this is to poke the application for various functions. For example, if the data set that you have, let's say this data set is for a banking website in which a customer has all type of accounts possible. So he has a certificate of deposit, he has a mortgage, he has a credit card, he has checking, saving, and also has some accounts where the access control is offered to his spouse and to his children. So these are some special control conditions. For that, you need special user account. That qualifies for control data conditions. That's why you need control data. Let's say my application needs some specific peculiar type of data that needs to be available to certify that the application is ready to test. Unless I have that met, I will not be able to accept the bill for testing. So I need, let's say I'm trying to test an enhancement in the application, which is to fix the access control that I share with my family members. So I have my son who is authorized to use my bank account, but he is authorized to see only a part of my bank account. He is not authorized to see my certificate of deposit, my mortgage, my credit card, but he can access the student account that I have created for him. So now you need data that meets that expectation, where there is a user who is a principal and a spouse or a son who is a secondary user. So that data must exist. So that's controlling. And in this data, I also need those bank accounts. I also need balances on those accounts. I need transactions on those accounts to be available for me to actually simulate that condition to scale. Does that make sense? Yeah. Okay. So, who are the team members who are responsible here? We have the QA architect. Why do we need a QA architect? Because he's the one who is responsible for creating the website architecture, my tools that are required to implement those tools in the environment. Then we need a QA analyst. Why do we need a QA analyst? QA analyst tells me that this is the data need that I have for executing the test cases. The business analyst is a part of the group because he is going to tell you these use cases have to be passed, only then you can start. Then a developer. Why does a developer come into QA world? Because you cannot survive without developers. Right? A developer needs to tell you. Sorry?
Problems back and forth.
Oh yeah. It's the process back and forth. That's what happens. This is the process, back and forth. It's always butting heads. Because, always remember, pointing somebody's mistake is not an easy job. And we are in the dirty business of pointing fingers. This sucks because it doesn't work. And you are the one who owns the code for that. If I'm blamed that I didn't do my job right, I'm not going to be a happy camper. I will do my best. But always remember, you have to have a very cordial relationship within the team. There is no blame game here, at least on the face of it. That's what it should appear. Internally what goes on, that's internal politics. That is different in every organization. Let's not worry about that. But for us to maintain a cordial team environment is very, very important. So, this is the test environment stage. Now we go into, we have planned everything under the detailed test plan. We have now set up our environment as well. So my next logical step is to start executing my test cases. So when I execute my test cases, what happens? I will create my test scripts that are done here. I will start working on execution of my test cases. I may need some changes to my scripts to match up with the data that I have, with the changes that have been applied to the application, or the additional data conditions that I want to add to my test cases. So that's where I need to make some enhancements as well. Right? After this is done, then we start executing. I start executing my test cases, and what happens when I execute my test case? Remember, in the initial moments of the class, you said, I will test and check if it meets the expected. So my test case that I have will have a test step. In that test step, I will have test data, condition, validation. Are those being met or not? Is my expected result same as my actual result? That's where my test case will pass. If it does not pass, there is a bug, right? So we have executed our tests. These are functional tests. Similarly, we will execute our performance tests. We will have stress tests, capacity tests, scalability tests, various types of tests that will be executed, and then we will look at these as compared to the actual results and declare success or failure. Once we have done this, we need to present the status to the team members. We need to present the status to the team members. That what happened. We will report that. So that's what happens now. So we execute the test and we report results. And how do we report results? We execute, analyze, and report. In the analysis part, what do? We measure the performance of the application. We measure, does the performance match up to what business wants? They want every page under load to be delivered in less than 2 seconds. Does it meet that requirement or not? We analyze the result, we compare it, and we assign the verdict. And then we look at the reporting of the defects, right? Once we start reporting the defects, what happens? The fixes will go in. Then the cycle of fix and test will continue. Once that is ready, which is in stage 8 of the software development life cycle, you will fix the defects, there will be a new build, it will be delivered to you. Once it is delivered, you will release the solution to your test environment. And once the release is done, you will do your regression test. And after you have done your regression test and you are satisfied that the build is now ready for release, it will be rolled out and will go to production. And then comes cheers and beers because the application is rolled out. But that's not the end. There is post-production support and maintenance that is required. The enhancements that need to be going into the application because of the change in business cycle. The business may want extension to the application. They may want to change the business process. Right? So this is an ongoing process where stage 10 is not the completion. Stage 10 is stepping stone into the next stage in the life cycle of the product. Till the application is sunset, this keeps on going. Because then what happens is, it goes into maintenance mode. First stage is development mode. So you're doing all this development, then you are in the testing stage. After testing stage, it goes into production support, then from production support it goes into maintenance. And once the maintenance is also over, that means the time to live for the application software or hardware is over, that's where it sunsets. That's where you call bit adios to the application. So this is, in terms of concept, theory, what we do. Now the next 7.5 days will be actual experience, hands-on with what we have seen here. How does it integrate with our day-to-day life? And with that being said, we are close to 1